Hello everyone, my name is Sai Harsha and I am here to explain about ER diagrams, some database design process. And uh, Normally the database consists of three schemas, which is conceptual schema, logical schema, and internal schema. Here we can see the internal schema where we store the data, and logical schema where we show the applications and how it is represented, and conceptual schema, and so it is also showed to some of applications uh, where conceptual requirements are there. So developing a conceptual model. Overall view of the database that integrates all the needed information discussed during the requirement analysis. Elements of conceptual model are represented by diagrams, ER diagrams, or entity relationship diagrams that show the meaning and relationship of the elements independent of any particular database or implementation of details. Can also be represented using model such tool as UML. We can also represent the ER models in UML in UML language, or it is a software tool which is used for the representation of UML. We can also draw the entity relations on paper. So we looked at the bus. So how we develop the ER models? First, we identify the entities and we give the related uh, attributes of the entities. The attribute nothing but the properties. For example, if we take a person as a entity, and the attributes would be the name of the person, the education qualification, the age, the height, and the weight. All these are the properties of the person, so we can represent them as them as an attributes. So we also have some unique identifiers, something like he's in brownish color. So if we take more than 5 to 6 entities, and we represent the relation between them. So normalization of ER diagram. So this is some entity relationship diagram. Here we have a customer number and dive, and here this represents an attribute customer number, and div plus is an entity, and it is a relation. A driving customer orders driving order, and the customer number and order number and drive item, and we shop via shop visiting, and it is an so it is generally drive through situation where driving customer orders and driving order, and the customer ID of the customer or the number of the customer, and drive item and the order number. And he may also shop something via shop, and shop via is an place where normalization, and the another slide would be here like this. This is some extended version. So a drive to customer orders a drive through order, and that drive through order contains a driving item, which is a food item, or it is and the food item contains order number, quantity, and item number. And is it on sale, or if it is not an food item, if it is not food item, and if it is an item which we buys, for example for toy, is it for rental or sale purpose, and the customer number. And we can shop via website, sorry, ship through we ship via website, and something like that. And coming to the diagram styles, we have different styles, and we have some notations, which is for means and for the relation. If we represent this between the two entities, it is exactly one. And if we draw this line between two entities, means one or more persons. For example, if we take one person, for example, if we take one person and number of items, if we draw like this, one or more person takes this item. This is so item, and this is an item, and we draw like this. Sorry, and this is a person. If we draw like this, means one or more persons go to the shop and buy this item. So this is a simple notation rather than writing one. This is some complex, but it is very useful. Generally, we write one n to n. So this is something we. So we can convert the entity relation diagram into relational tables. We each item is converted into a table. Each many to many relationship or associated entity will convert into a table. During this conversion, certain rules must be followed to ensure a foreign key appears in the proper place in the table. As we all know, the foreign key and simple converting a simple entity. And we have a simple entity called salesperson. And the salesperson has number, salesperson name, and salesperson commission percentage year of it. And we converted this entity into some table like salesperson number, salesperson name, commission and percentage, and year of hire. We can say that. And this is the simple entity conversion. And converting entity in binary relation of 1 to 1 means if this entity is connected to this office entity, salesperson entity is connected to office entity, and it is one-on-one relation. And now we can convert this one-on-one relation into the tables like this. And this is a and this has many attributes, as you can see: name, salesperson, commission, year of hire, and the office has office number, telephone, and size. And if it is a one-on-one relation, here we can see the salesperson name, number, salesperson name, commission, year of person, year of hire, office or telephone or office telephone number, and the size office. And this is option number 2. Separable tables for salesperson and office entities with office number as foreign key in the salesperson table. In the previous one, we have created only one table for the both entities, and here we are creating separate tables for the two entities, and we are using the office member as a foreign key, which means in the office table, the office number is a primary key, and here in the salesperson table, the office number is foreign key. And the third option, separate the tables for the salesperson and office with salesperson number as foreign key in the office table. We can also have salesperson number as a foreign key in the office table and salesperson number as a primary key in the salesperson table. And it is another way. And, here are some uh, and here are some options. And thank you.